We will talk about the scope of a variable okay. Let's take a simple example. Say void, name of the function is first, doesn't take anything. Let's say integer x equal to 20, and that's it. Then void, take another one, second, and integer x equal to 30, and our main function. Okay, say x is equal to 40, and I print here. Okay, print f(x). Now if you look at the scope of this variable x, okay, it only the lifespan of this variable x exists only during this function call, during the execution of this function. As soon as this function completes execution, this variable x is no more visible to anybody. And so is this function second. Here the value x is equal to 30. It only valid till the lifespan of this function. Outside this function, this x, the value of x, now the function called exists, right? So the scope is only within this function, especially for local variables. They're not visible outside here. Okay, even though x is equal to 30 here, when I do it, let's say I call, give me a second here. Let's say my main function, I write, sorry, my main function here, I call the first and then second, right? And I say x is equal to 40. So when I call first function, the function first, it initializes the variable x equal to 20, and at this, between these two function calls, this x is not visible at all. This is dead, right? And so is here when I call second, when the function starts executing and completes the execution of this function, that variable x is not visible in the main function. It's the x is equal to 30 is done. And here, let's say I have integer x. This x is not addressing or referring to this x's here because they are not visible at all to the here. This x refers to the local variable x in here. So the scope of a local variables in C language are limited to the lifespan of that particular function call. Function call, remember. Okay. Okay. So let's take a simple example here. Scope So I have define this function first with x is equal to 20, second x is equal to 30. I've initialized x is equal to 40 here, I'm calling the function first, and I'm printing after call, first call, x is equal to so much. Then I'm calling the second function, and again I'm printing the value of x. Okay, let's compile this program. GCC scope. If you do it here, you see here x is always 40. No matter how many times you call those functions, will always remain 40, because this value of x that we defined belongs to the function, local functions. These are local variables belong to those functions. Changes to those variables, even though they are same, named as same, they do not affect the other variables in other functions. Okay, so that's one. Let's take another example. I'll copy this scope to scope 2.c. Okay, scope 2.c. Now I'm going to change here. I removed my main function. Okay, let me comment it out. Now what will happen to this x here? You pause the video and take a minute to evaluate and then answer a question. I have removed this integer x is equal to 40, and what will happen? What do you think will be printed here? Do you think it will compile? It will not. Why? Because this local variables belongs to these functions. Main program function have no access to these variables. It will not. So you will get a compilation error. See, x is undeclared, right? Let's go back. Let's copy scope 2.c to scope 3.c. Now I going to declare integer x is equal to, say, 10, and I am going to now you tell me this program here. I have declared a global variable in here. It's a global variable. That means it's visible to all functions in the program. And I have changed, I did not declare, but I'm calling the global variable equal to 20. So it changes the variable. It refers to the global variable. How about here? Same, right? It refers to the global variable. Yeah. And here again, the main function, when you print, it refers to the global variable, right? See how the visibility of variables across the functions when it comes to global variable. Now what will happen at launch? X is equal to 10. Then main function get executed. First it calls the function, and when you say x is equal to 20, it changes the global variable, because there are no local variables within the function, within the first. right? And then we print x is equal to after the first call. Now you pause the video and answer this question. I'm calling second now. What would be the value of x in here? Okay, so that is how global variables are accessed, and they are visible across all the functions, right? So if you compile this program, oops, I changed the scope. Uh, okay, scope 2. See it? It will change. If you go back to the function now, scope 2.c, this function changed x is equal to 20. So when I printed, it printed correctly. Then I called second function, it printed 30, right? Because we are changing the global variable. Now I'll change this program again. Okay, now I'm copied the program to another program, scope 4. Here the global variable is 10, and the first program it changes to 20, but in the second function I'm going to declare another variable integer x here. Okay, pay attention to this. Attention to here. I have a global variable 10. In the very first call, first I changed it to 20. That means I'm changing the global variable. In the second function, I have integer x is equal to 30. So what does it mean? It has the same name as the global variable. First, is it valid or invalid? Can we have the same global variable in the local variables? You betcha. You can have it. So what really happens is, when you declare variables like this, I can change x equal to again so 40, whatever. This x always refers to the, you can say, the nearest declaration. In this case, it is a local variable. Okay. So it hides the global variable x in a, you can say here, hides the global variable. You cannot access global variable in this function because you have declared another variable integer x. Why is that? Because that's the way it is. There is a concept called activation records. We will briefly touch upon that. Anyway, so it hides this global variable. So if you go and print here, first the value 20 here, and in the second function the global variable is unaffected because it deals with the local variable itself. And when you print x, the value of x remains 20. So you'll see 20 printed here and 20 printed here. See that? 20, 20. So you always pay much careful attention to naming local variables, they should not conflict with the global variables, because you may intend to change the global variable here actually, but because you declared integer x already, it didn't complain saying duplicate variable declare or anything like that. This is completely valid. Okay,